Algebra 2, Concept 7A. We're going to continue what we've been learning in Concept 6 with quadratic functions. Now we're going to focus graphing quadratics in their three different forms. In this concept, we're going to focus on the form that we've been talking about, which is vertex form. So go ahead and rewrite that general formula that I know you're used to by now. So f of x equals a times the quantity x minus h squared plus k. And then write down again that the vertex is located at hk. The vertex is the highest or the lowest point of the parabola, which we've talked about. And now we're going to add something else to our vocabulary of quadratics. The axis of symmetry. So this is an invisible line that runs right down the parabola, the middle of the parabola, and divides it in half. And then we can write an equation for that vertical line that x equals whatever the h value is in your quadratic equation in vertex form. A maximum or a minimum of a parabola is either the highest or the lowest point. And now we're also going to talk about domain and range of a parabola. So your domain is a rule for the inputs or the x values that will give us real number outputs. For a quadratic, the domain is simple. We can put any number in for x. So our domain we will always identify as all real numbers in a quadratic. Our range will change based on the equation. So a range is a description of all the possible outputs or y's that you can get in a quadratic equation. It will be that y will be greater than or equal to the k value if the parabola is opening up. If the parabola is opening down, then our range rule will be that our y values will always be less than or equal to the k value. If you need to, pause the video to get down those definitions. And now we'll start graphing. For each different form of a quadratic equation, I'm going to give you steps on how to graph them. So these are the steps on how to graph a quadratic equation if it is in vertex form. The first thing we'll do is that we will look at the equation and anticipate any transformations that we know will happen. And that's what we learned in Concept 6. So do we have an x-axis reflection, or a vertical stretch or shrink, or a horizontal shift left or right? So we're going to find the vertex, and we will do that by picking out the h and the k value. Just remember that the h value will always be the opposite sign than what you see in the equation. Then we're going to find the axis of symmetry. That's that invisible line that runs down the middle of a parabola that divides it in half. It is so simple because it's a vertical line. It has the equation x equals a number, and the number is going to be the h value, or the x value of the vertex. Then lastly, you're going to make a t-chart, and then from the vertex plug in two values in the negative direction, and that's going to feel familiar because we did that in Concept 6, and then 2 in the positive direction. And then you'll have 5 excellent points to graph your parabola. Okay, think about the general form of the parabola and the a, h, and k values, and let's pick them out. So our h value, we see a plus 3 there, so that means our h value will be a negative 3. And then our k value is just as we see it, so that is positive 4. And then we can go ahead and write our vertex in an ordered pair. So it is negative 3, positive 4. And let's go ahead and write our equation for our axis of symmetry. That's what that stands for. So it is going to be the vertical line with the equation x equals and then negative 3. Now let's place our vertex in the middle of our table like we've done before. And then we're going to have two x values in the negative direction and then 2 in the positive direction. Now as these equations get more complex, you can use your calculator to help you out. So remember, and let me go ahead and do what we've done before. Just write the equation that we're finding points for just here. So remember, each of these x values in your table, you're going to plug them in one at a time into this equation for x. So a little calculator tip is you can plug it in as you see it. So as I'm writing it, now we're going to put in -5 for x. You're going to plug it in as you see it. And then you're not going to press enter until you have everything in there, because the calculator knows order of operations, and it will do it in the correct order for you. So it'll take -2 and add 3, which will give you, -5 and add 3, which will give you -2 and square it, which is 4. And then take 4 times -8 times -2, which gives you -8. And then it'll add 4, which will give you -4. So then just continue and changing that x value each time. If you're having trouble with your calculator, ask a friend or one of the instructors to help you. You should get +2 here. Alright, I'll show one more plug-in. So every time the equation is the same except for the x value. If you plug in -2, you'll get +2. And then if you plug in -1, so you do that on your own, you will get -4. On your graph space, remember always to draw your XY axis and label and your scale. You'll need to do that all throughout the unit and on your unit test to get full points for your graphs. Okay, so now let's graph these. So we have -5, -4, -4, +2, so we're jumping up there, -3, +4, -2, 2, and -1, -4. Now I could tell just by the equation that I was going to have lots of different transformations. So I would have an x-axis reflection and a vertical stretch because of that a value. I'm going to be shifting to the left 3 and up 4. So that is exactly what has happened. We have shifted to the left 3 and up 4, and then our graph is skinnier. Now the last thing is domain and range. So remember how I told you that the domain of a quadratic is all real numbers. So you can just write that symbol. It's a capital R with an extra leg. Now our range is going to be different. So you can look at your graph and you see where the graph starts with the y value. So it's right where y is +4, and that is our k value. And then notice where the graph falls. It's this way. So all the y values that are less than +4 and equal to. So we'll say our range is y is less than or equal to +4, which is the k value. So that's how you can find your domain and range. Now look at example 2, and let's anticipate all the transformations. So if we look at our equation, the first thing we see is this a value of 2/3. So it is less than 1, so that means we're going to have a vertical shrink. Our graph is going to be wider than the parent graph. We have an h value of 3, and it's x minus 3, so this graph is going to shift to the right 3 and up 7. So our h value is +3, it's opposite of what we see. Our k value is 7, and then those two values form our vertex. Our axis of symmetry is where x equals that h value. And I forgot to dash that in last time, so we'll do that this time. Okay, so let's put our vertex at 3, 7, and then we're going to go in the negative direction and in the positive direction. Now remember, you can plug in, so we have 2/3. You can put it in as a fraction form, or you can put 2 divided by 3. And then we're going to plug in our x value. So in this case, we'll start with 1, and then minus 3 quantity squared plus 7. You can just plug this in to your calculator and then press enter. Now sometimes you're going to need to round. So we are going to round on this one. So at positive 1, we're going to have 9 2/3 basically, so 9.7. Now I'll write one more time how to plug this in your calculator. So 2 minus 3 quantity squared plus 7, and then we'll have 7.7. If you plug in 4, you will get the same as if you plugged in 2, 7.7, and then 5, the same as plugging in 1, 9.7. So again, if you get a decimal, just round to 1/10 place and then estimate when you graph. So we'll go over 1 and then up 9.7, so almost to 10, not quite. Over 2 and then 7.7, so about close to 8. And then 3 will go up to 7, 4 back there, and 5 up to 9.7. Now, can you see how this graph is wider than our typical parent? It is also shifted quite a ways, and we anticipated that. So it shifted to the right 3 and up 7, and it is a vertical shrink. Now, remember the domain? Yep, all real numbers. And then our range is going to be, since it's opening up, greater than or equal to, and then look at the k value. You can also see, so that'd be 7. You can also see where the graph starts right here, and then how it opens up. So all the y values that start at 7 and are greater are being used to create that graph. Now you have a couple graphs to do on your own in the independent practice. So pause the video and graph those, and then come back and check your answers. So your first graph should look something like this. It should open down and be narrower than the parent because it's a vertical stretch. It should also shift 1 to the left. And this time I finally remembered to dash in the axis of symmetry. So if you haven't done that, do that on your graph. So that is the vertical line, and it's not a hard graph. It's an imaginary line, but yet it is there. So that's why we dash it, and that just indicates it's like a line of symmetry, an axis of symmetry for that. Your domain, of course, will be all real numbers, and then notice how the graph of the parabola starts at the y value of 0, and then the curve is across from all the y values that are less than or equal to 0. And finally, check your graph on number 2. So you should have identified your h and k value is 2 and 5. The vertex then is 2, 5. Axis of symmetry is 2, and you can see that I have that dashed in there. Your domain will be all real numbers, and your range will be y is greater than or equal to 5 since the graph is opening up. Also notice on this one and the graph on number 1, I just shifted my axes a little bit off of the middle of the graph, so I had enough values to graph, you know, that high y value that I had in this number and then the low y value that I had. So you can do that. You are a master of your graph, so you can shift around, you know, where the your x and y axis on the graph space.